Howdy, I'm Professor Parks, PhD, and I make content concerning astronomy, mental health, and science skepticism. And this is becoming my continuing series, Shouting into the Void, where I start my day by just shouting into the void. So if you like this sort of thing, please hit like, share, subscribe, hit that bell for notifications, because I tend to be fairly chaotic when it comes to posting stuff. And so this is probably going to be a short stream because my semester starts tomorrow. Tomorrow, I love you. Tomorrow. Anyway, sorry about that. So, as I say, I will be, this coming semester, I will be teaching my staple, which is ASTR 103, Introductory Astronomy is the name of the course. It is a semester-long survey of, well, as you might think, astronomy. And I will be teaching 4 recitation sections of physics dos, electromagnetism, and optics. So I'm pretty excited about doing that. But anyway, just a check-in. I'm doing all right. Yeah, that's basically it. I'm doing all right, and you know, we'll see how it's going. Howdy, Clive. Are you teaching how to use the P900? I am not, actually. No. That would be more useful for ASTR 124, which I don't teach, but I may be able to convince my director to let me take over at some point, because he is oversubscribed. And yeah, that is our observational techniques class for freshmen and juniors, or freshmen and sophomores. And so maybe, just maybe, if I were allowed to teach that class, then yes, we would no longer use our 32-inch telescope. We would strictly use the P900, the camera of choice for all those who wish to know about the heavens. So also, I'm probably going to play around with something while I do this, so you'll have to kind of bear with me. Here we go. Let's pop this out. I noticed on other streams that folks have their chat in the screen or in the stream, and so maybe I can actually do that. We shall see. Let me see. Camera slot. There we go. How about that? Here we go. And add item, media slot. Okay, that's not what I was expecting it to be. No. All right, so this is actually going to take more fiddling than I want to do with right now. So whatever. Whatevs. So what I want to do is, so yeah, starting off with, I've got the chat over here. Starting off, the most important news, or at least the news that I'm most excited about, actually, is that I am now getting that sweet, sweet NASA money. You may notice that in the chat, there is this little box with a $sign. Those are super chats. I have been over 500 subs for a while now, and I do intend to have a 500 subs celebration, but I was not up on views. I did not have the hours, apparently, the 3,000 hours or however many it is for, you know, full on monetization. So, but yesterday I actually surpassed that. So now I can get that sweet, sweet NASA money. So just a disclaimer. I know I hate talking about money, but you know, that makes the world go round. If you wish to support this channel, you can please consider becoming a patron of mine or sending me funds through PayPal. all of those funds will go towards the observatory and the student club organization. However, super chats and memberships on this channel will go to me, because one of the reasons why I am doing this is because I need a second stream of income. And so, yeah, I don't know where that's going to go, how much income that's going to generate, but I just wanted to be upfront and honest about where your money is going if you were to choose to support me in this little adventure that I am growing more and more confident will actually become something of a second career. So anyway, how are you doing, Dr. Wells? That reminds me. So this coming Sunday is probably going to be a big day, assuming my health holds out, my energy levels hold out. Sunday is going to be a big day, for at least for me, in that I have already requested. I've made recent acquaintance with the grandson of Van de Graaff. He is a postdoc, a newly minted PhD, and a postdoc. I don't know exactly how much information I can blur out, so I will leave it at that. He is a physicist, and I am hoping. I've reached out to him, and he goes by the name Tapioca Weasel, Dr. Tapioca Weasel on YouTube. I've reached out to him, and I'm hoping we can set up a Coffee and Science interview on Sunday morning. Other thing that I would like to do, and this is where Dr. Clive Wells has reminded me, is that I still want to be able to do a forum with various doctors of various different scientific fields so that we can discuss how the scientific method is performed or utilized across various fields. Again, I am an astronomer, so I am only really aware, because I've only really done astronomical research, only aware on how astronomy is done. And if you're interested in that, the previous volume, volume 6 of Shouting into the Void, I spend a good deal of time going over a paper, my most recent paper, and I highlight how the paper actually follows the scientific method involving different types of variables and what are the things that need to be things that are overlooked in a general discussion of the scientific method, such as error calculations or the justification of the quality of fit for your research, such that you can have confidence and instill confidence in your readers that you actually know what the hell you're doing. So yeah, check that out. I may remember to put that link in the description. So there you go. Howdy, Fred. Morning. And yeah, so I'm hoping to be able to do that. And I'm hoping to be able to do that Sunday evening, because at least two of the gentlemen I hope to convince into doing this are Dr. Tony, PhD Tony, and Professor Phil Bell, both of whom live down under. And so I think that might work in terms of time. Dr. Clive Wells, you were, of course, invited, and a few others. And so what I'm going to do, I tried to reach out on Discord, wasn't overly successful. So I'm going to actually get a little bit more rigorous and see if I can email them or track them down in real time, I guess, to offer that invitation. And then the other thing that I'm definitely going to do, if I get enough people on board, I will do that. I will do the scientific method forum. But the other thing that I'm going to do is I am actually going to have a celebration of my viewership. Yay! I surpassed that milestone of 500 subs. I'm now monetized. So I am, I want to do something to celebrate that event. And I don't know exactly what I'm going to do, which is probably why I haven't done it. So I'm just going to pull the trigger on it and basically probably make it an open stream where I just give a link, StreamYard's link to folks. And if they want to pop in, have a chat with me, discuss skeptical science or science skepticism or the Packers, who just thoroughly thrashed the Cowboys. Hell yes. Basically, or any really other sport except for cricket, because cricket's not a sport. Sorry, I couldn't say that with a straight face. So yeah, anything anybody wants to talk about, they can come on in and we'll jaw it out. And I'm willing to let that go for however long I have interest. So again, all of this is predicated on my energy level, but I have an open Sunday, completely open Sunday. I will not be scheduling anything on Sunday. So hopefully all of that, the coffee and science, the scientific method forum, and the celebration will all happen on Sunday. Cricket is the mark of a civilized nation. Okay, sure. Agree to disagree, but all right. As I've said before, any sport that needs 5 days in order to figure out a winner, I think they need to rethink their priorities. And I do realize that's only one specific form of cricket, but still, it's nuts. And it's akin to baseball-ish. It's baseball adjacent. And I think baseball is one of the most boring sports to have ever been invented. So if I had to watch that for 5 days to figure out who wins, no, sir. Anyway, so like I said, I have a lot going on today because my semester's starting tomorrow. So I don't know. These things have been running for the last few volumes have been hour and a half, 2 hours. I doubt I will be going on that long today because, like I said, I've got a syllabus to edit and things to post and an observatory to clean up. The storage rooms for my observatory for the observatory are embarrassing. They're probably more disorganized than my flat, and that's saying something. So essentially rounders. I actually am not familiar with the game of rounders. This says to show in full screen mode, new private chat messages. Oh, I see. Well, I was hoping to be able to actually see, chat messages. Oh, well, I'll just see it over here. Hockey. I hope you're not referring to hockey as a girls' game there, Fred. Hockey is my true love in terms of the sports arena. I am a diehard Tampa Bay Lightning fan. I was there for probably not. I don't think I was there for the first game, but I was definitely there for the inaugural season when we were in the barn. We were basically the Lightning played in a rink in the Tampa or the Florida State Fairgrounds for a year. So I can say that I've been there since the beginning of my my sport. So oh my God, yes, hockey is a what? Them be fighting words. Hockey is mostly played by you're talking about in the UK? Really? Hockey is mostly played by girls when boys play football and rugby. Wow. Okay. Yeah. Okay. All right. I do not understand that. Although I understand sort of the difference between rugby or the choice between rugby and hockey, but I think that should be open to both genders. I mean, I think anyone should be allowed to smash another person to the ground. going after either a small rubber puck or inflated ball. It's about as far as I get to willingly endorsing physical violence onto another person. Although I have been rethinking my, not to get too serious and deep into sports, I have been rethinking my fandom of football because, well, it is fucking people up. It is, concussions ain't good. Long-term brain damage ain't good. So I don't know if I can support that kind of thing, but I still do. So we'll see how it goes. Anyway, ice hockey was invented by British soldiers in Canada. I did not know that. I actually did not know that. Was Lord Stanley a Brit? I mean, he was a lord, so I'm assuming. Were there ever lords in Canada? I actually don't know. Showing my American is showing. All right. But what I wanted to kind of touch on today, and I will freely admit that I have not actually read this paper all the way through. All right, I'm going to have to do this. And all right, let's put this over here. And go back to here. Present. Share screen. That one. I thought this was a fairly interesting or provocative paper. And it's recent. It's 2020, July of 2020, and it's in the Journal of Applied Optics, which I am assuming is a quality journal. I am at the moment, unless someone tells me otherwise, I am assuming that this is actually a pretty rigorous, valid document. Don't want to do that. Don't want to hide the chat either. So, called Below the Horizon, Physics of Extreme Visual Ranges. Now, the paper is talking about essentially visible ranges up to 440 kilometers have recently been documented by photographs for ground-based observers. So the idea here is, why is it that we can see too far? Why is it that we can see objects that would be obscured, blocked by the curvature of a geometric sphere of radius of the Earth, the 6,000 whatever, I don't remember that number. As much as been quoted around, I still refuse to memorize the number. So the idea here is, how is it physically that we can do this? But what I find to be most impressive about this, as far as I know, again, I haven't fully read it, I've skimmed it, but when people have approached the seeing too far argument or discussion, they always seem to be talking about, the drop or the amount of obstruction, the height of the sagitta, or whatever you want to call it. And this is specifically for Dan the Waterman, if he happens to be watching this. When I go through this paper thoroughly, I definitely plan on contacting him and possibly going live to talk to him about it. Is that, Dan had a series of, Dan and some others had an experiment that they ran where they shot a laser beam across a theoretically flat surface over the distance of miles, tens of miles, I believe, like the Salton Lake Flats or I don't know, the S Flats, whatever they're called. Ground level or ground salt flats that are very, very level over a very, very large span of distance. They shot a laser, hit a mirror, it comes back, and because of the fact that it's so large, it's larger than a geometric sphere would allow for that laser to bounce there and back based on the altitude or the elevations or heights of both the laser and the mirror. So he has been touting this for a very long time now, that this is definitive proof that, or solid evidence that the Earth is in fact flat, and he rejects the idea that the idea that this is atmospheric refraction, because he believes that in their experiments that has been essentially canceled out because of the various weather conditions that happen during these observations. That effectively shows that refraction is not a viable explanation for why they are able to see at such long distances. And in my last conversation with him, I put forth that and he also was talking about, the Metabuck calculator, how much can be obscured, yada yada. And I frankly got kind of frustrated, and I was like, I don't care about that. That does not tell me anything. What I am most interested in is how far, given the globe model, how far would you expect to see given the weather conditions at that time? And, and I, at some point, I think actually said, hey, I will actually look into this. I will see if I can find a way to figure out, given the data that he provided, how far one would expect to see on a globe, and if the distances that he is measuring from are shorter than that limit, then to me that effectively tells us that experiment didn't tell us anything. Not that it proves that the Earth is a globe or proves or disproves that the Earth is flat. It just simply says that the globe still allows for that type of observation to be seen. So anyway, when you think about the question of seeing too far, when you think about, can I take a laser beam and I shoot it out over some distance and I hit a flat mirror and it comes back? Now there are a number of things that need to be taken into account, but this paper talks about two things most specifically, and those are, of course, how much the light beam refracts through an atmosphere based on the lapse rate, which is essentially the temperature differential from ground to higher up. Because the way that atmospheric refraction works is that light bends when it travels from one index of refraction into another different index of refraction. And in a very simple way, you can imagine that the atmosphere is like an onion, that you have shells surrounding the globe, and that each shell is itself a different index of refraction from the one below it. Again, oversimplification, but to first order, you could think of it that way. And so as a light beam travels outward from a single point on a sphere, what's going to happen is that light beam is going to gain altitude off the Earth's surface. Therefore, it is going to move further up into the atmosphere. And I know that might seem weird. The beam is horizontal to the surface, but it seems to be going up through the atmosphere. I don't have the time or the resources to really draw that out, but just, take a sphere, draw a circle, and draw a straight line off the top of that circle, and look at the distance between that line and the surface itself. And hopefully you can see that gets larger as one moves away. So you are moving through different layers of the atmosphere, and therefore you're expecting that the light will experience different indices of refraction, and therefore the light will bend. It will curve to follow the Earth's surface to some extent or another. The other issue is whether or not the light is strong enough to get there. Now, people have talked about this diffusion of light. Basically, if you have a laser beam is very, very collimated. It's very, very concentrated into, well, a beam. But as that light goes out, it's going to, and I'm probably using the wrong word, it's going to diffuse, or it's going to spread out into a cone, and it's going to get larger and larger. And since the energy of the laser, the actual light within the laser is constant, if you spread that over a larger area, the overall brightness of that beam is going to decrease. But something else that happens is that, and this is perhaps, in my opinion, probably more relevant, is opacity. In lack of a better term, just to kind of go back to astronomy, one of the things that we have to worry about is basically whether or not the light actually gets to us from the source. And we talk about that in terms of opacity. For example, young stars embedded within molecular clouds or stellar nurseries, that light or that cloud is pretty much opaque to visible light. That visible light coming off of that protostar moving towards the Earth cannot penetrate that cloud. That light gets bounced around and just dispersed out of our line of sight, and not enough photons actually get to us. However, that opacity changes in the infrared, which is why we can make these studies. Same thing happens here, just to a much lesser extent. Although, if you've ever experienced fog, this is essentially is that fog. When you have fog, you have water vapor in the air, and that will it will scatter the light out of your line of sight. The daytime sky, you have Rayleigh scattering. You have the light from the sun is coming down, hits the atmosphere, and because of the atmosphere and Rayleigh scattering, that light gets dispersed all over the visible sky, and that is what creates the sky brightness of the daytime sky, hence why you can't see stars. If we didn't have an atmosphere, we would all die, but before we all suffocated and froze to death, we would be able to see stars popping out in the night sky, or in the sky, as less and less of the light gets diffracted or scattered. So this gives me a few equations, and it talks about the visual range within normal refraction. Gives this these ideas of, if you have r is the radius of curvature of the refracted beam. If that radius is infinite, then you basically have a straight line. The light is not refracted at all. And then as you change that, as the lapse rate or the variable indices of refraction change the radius of curvature, then the light begins to bend. And sometimes it will bend and actually hit the surface itself, theoretically, if the values are correct or values are nice. And so it goes into what factors, you have lapse rates, that vary so you have the characteristic lapse rates, run from anywhere between 6.5 to 10 Kelvin per kilometer. And then you can use that to, figure out you can figure out the lapse rate alpha needed to produce rectilinear light propagation, the ones for lights circling the Earth at a constant height. So essentially, here you can see that this would cause the light. My interpretation is that the light is now maybe no longer. Well, no, I won't say that. Yeah. So, again, I've skimmed this. I need to look at it with more depth. Scattering needs a container. Yes, it does. So what was I saying on this? So yeah. So these are variables that need to be calculated to figure out exactly how things curve or how things bend. One of the things that I often hear from flat earthers is that I do not believe that the light can bend so much that light can actually depart from straight so much in order to make that such a large cover such a large ground. I think even Dan has said something to that effect. And hopefully with these calculations, and because what I'm planning on doing is I'm planning on putting all of these equations together, figuring out if I have enough information given his data, and I'm going to calculate how far one can actually see with those conditions, with those things. But the other thing is visible range due to absorption and scattering in the atmosphere. Basically, now we are dealing with opacity. This should not affect Dan's observations, because I don't think the distances are large enough for the light, the laser light, to be attenuated so much that you would not be able to see it. But this informs on conversations like the Michigan skyline. Why is it that you can see the Michigan skyline on some days and not on others? Well, one of the reasons is obviously the light refracts differently due to weather conditions. But I would also have to say, I would also contend that this is also a factor. If you have a lot of, lower level fog, which I believe is fairly common in that area. If you have a lot of low level fog, then that can also cause the light just simply not to be able to get to you. If you had no fog, the refraction is high enough for you to actually be able to see the Michigan from wherever else, from the other side of the lake, or Chicago. Sorry, you'd be able to see Chicago from Michigan. And so that is also something that needs to be considered. Again, for Dan's observations for Salton Sea, that's what it is. The Salton Sea, for those of you, or for those blah blah blah. What am I talking about? For those observations, again, the distances are small. Let's see. Clive says these equations are not well written. They seem to have missing units. Yeah, I was disappointed in that I could not, given the title of this thing, talking about range, there is no one equation to calculate it, or at least not one that I've been able to find. So again, I've just skimmed it. I'm assuming that it knows what it's talking about. When I dive into it a little bit more, hopefully I can better evaluate it. And right after this stream, I will post it to my Discord, and which I will do this because I'm copy link. Whoops, that's not what I wanted to do. Invite people. All right. Okay. That is a link to my Discord. If you are interested in joining the discussion on this, please do. What I'm planning on doing is, what am I doing? What I plan on doing after the stream is posting this paper onto Discord and sending it to a couple of other folks who are sadly not on my Discord, and having them have a go at it and see if they can spot egregious errors in either the logic or the equations themselves. But I just find it, I'm intrigued by this paper because of the fact that it actually goes into what I think would be the best counter argument to we see too far, more so than the whole, covering obstruction business, yada, yada, whatever. So, because if you can show that given globe math, globe physics, that you could potentially see to a distance of 100 kilometers on the globe, then if you do a laser test whose extent is only 20 kilometers, you haven't shown anything. So what you own, so if you were to develop, and this is out for all the flat earthers out there, what I would suggest you do, and I have no idea where you would be able to do this, but what I would suggest you do is you're going to need to do long distance observations. And you're going to, well, first, what I would do is I would go through, if I can figure out that the math is good and all that, go through the math and find out what your expectation would be. This is essentially how one builds a hypothesis. And howdy, Al. This is how one builds a hypothesis, is that you research the topic, you research I got my first super chat. Thank you, Judy, for 10 euro. Yay! Got my first super chat. I would put it on the screen, but I don't know how to do that yet. So yes, thank you very much. And Judy says howdy to all of you out there in the internet land. As I was saying, if you're going to test anything, the first thing you need to do is you need to research the topic, and you need to figure out, and from that you can construct a hypothesis. The next stage is, from that research, you can then devise an experimental design that will actually test that hypothesis. And for this, I think one of the vital things that is skipped, or one of the vital things that is missed, is that when you do a laser test, a range finding laser test, it's optics. Whether or not you believe it or not, and this is baked into your hypothesis, it's going to refract according to the globe. According to mainstream science, those people who are saying, no, your observations don't show what you think they are showing, we stand by that the light is going to refract. And so if you're going to shut us up, the best way to do that is to use the globe model, to use the amount of refraction that the globe would accept as accurate, and figure out what is the furthest extent you would be able to see on the globe, and then devise a test where the laser and the mirror are farther apart than that, because that would falsify it. Well, it would falsify it in a sense that you're left with two options at this point. If you can actually truly see too far, then your options at this point are A, that the Earth is flatter than the globe predicts, or B, 2, the amount of refraction that is happening is not as predicted, that somehow our understanding of how light refracts through an atmosphere is not true, or is somehow incorrect in this particular case. That is how one would properly do this type of experiment in order to really have a strong argument as to whether or not the Earth is flat, or whether or not the Earth is curved in some way. And so that's what I'm hoping to be able to do. And in a stream in a galaxy far, far away, a long, long time ago, I mentioned how I was keen to develop an experiment, and I was talking to one of my patrons, Norm. I was texting him a couple times this morning, and Norman wants to do basically a curvature test, not a line of sight test, but something else. And his original setup, because he is an engineer, he worked it out on paper and realized that the setup that he intended to use the measurement was actually too small for his instruments to measure. Essentially, he would not have the precision to actually demonstrate in one way or the other what he wanted to demonstrate. And it got me thinking, that's what reminded me of this, is that I would like to work with flat earthers and develop a test to see whether or not the Earth is a globe or flat. Something, because, folks have done this sort of thing. MC Toon, for example, has done it. It's on his channel. I Can Science That has done a very similar experiment. It's on his channel. And yet when they present these experiments to flat earthers, they reject them. They will not accept the results. And so I think the next step, if we truly want to have this conversation be less combative or more productive, then I think that a group of flat earthers who are open to be, who are truly open-minded, and a group of globers who are sympathetic, have these two groups meet and discuss and work out what experiment can be devised that could truly demonstrate or test this particular hypothesis, whether or not the Earth is flat or whether or not the Earth is curved or has any kind of curvature. My hopes of getting those two groups together is going to be a challenge. I have just simply put out that notion, and I've talked to Dan about it. I think I've talked to Austin Whitsitt about it, and in principle they agree, but nothing has been done. I think I've talked about it to I Can Science, may have mentioned it to MC Toon, and I mentioned it, nothing has happened. So I think if I truly want this to happen, I need to be more proactive. I need to see if I can actually get the groups to talk to each other. Now, do I expect productive talks? Honestly, no. I suspect that there will be a lot of roadblocks in trying to work out what this experiment will be, because we still have that same disconnect of what is thought of or what is evidence. What is that? What is it that you would? What is it? What type of evidence would certain people accept and reject? There's been all kinds of theories thrown out there as to why science skeptics do not accept certain evidence, but I don't really have the time or the inclination to go over that today. But anyway, so like I said, the Discord link is in the description. I found this paper for those of you who are unaware, who are coming in late. This is a paper which talks about they're seeing too far, what kind of the math involved in figuring out just how far one should be able to see on the globe given a reasonable temperature profile to the atmosphere, which is essentially what, from my understanding, what dictates or what the major component to being able to see too far. It also talks about the refraction or the dispersion of light, essentially that light gets scattered out of your line of sight as it progresses through a non-empty atmosphere, and so that will attenuate the light. So that is what I was talking about. Howdy, Thurston. Bearing to the sun at 6 hours after local solar noon is my favorite flat/globe test, whereas Wally has a nice video pulling together observations done by multiple people. Thank you for that, because on my Discord, I have a section now called channel recommendations, and I need to figure out, I think Wally's on there, but if not, then he certainly will be later. The observation should be done on the equator or on the equinox for the simplest prediction for flat Earth. Yeah, I believe that is the bearing to the sun is, I believe MC Toon also did something very similar. May be the same experiment because he did it with a couple of other collaborators. And yeah, but as I was saying, when Toon has, and presumably when Wally has shown this test, has shown this evidence, it has been flatly rejected. And I think the only reasonable solution to this is to have flat earthers, prominent flat earthers, involved in the experimental design process, so that when the results are found, they will accept it. Now, you can argue all all day as to whether or not, as I've said, whether or not they would actually be able to complete the design process. And you could also make predictions as to the honesty of the flat earthers after the fact. I still think that, or just to be fair, Globers, the honesty of anyone involved in this project, or the openness to work with the other side in this project, not to just bash on flat earthers, but I think this is the only, or this is the best reasonable way to talk about Earth curvature with line of sight tests. Because again, refraction is not treated well in the laser tests that I've seen, the distance laser tests that I've seen from flat Earth. So, all right. Let me stop sharing that. Oh, cursor's over here. Yay! So happy. Thank you, Judy. That's just fantastic. I really, really appreciate that. Start. There we go. Okay. It's just a start. All right. But I've never had a super chat before through StreamYard, so it just something new popped up. And so I was like, all right, sweet. And really, yeah, that's all I really kind of wanted to talk about today. Trying to think of anything that's pressing with me or that it's been on my mind to just get off my chest. The only thing that really pops into my consciousness at this moment is the Euclid satellite. Euclid, for those of you who don't know, is, in my opinion, the proper successor to Hubble. But because it was made by those dirty Europeans, we Americans don't really talk about it, which is a crime. Euclid, for those of you who don't know what it is a optical / infrared space telescope at the L2 Lagrange point. If you've heard of the L2 Lagrange point, you probably have heard it with respect to JWST. This is a stable point in a three-body problem. So you have the Earth, you have the Sun, and then you have the satellite itself. And through our analysis, we have shown that there are certain points within that configuration where something can stay and not be accelerated in towards any other, either of the two bodies, Basically, it's a stable or quasi-stable point. And L2 is one of the stable points that's on the opposite side of the Earth from the Sun. So it's ideal for satellites to be located there, particularly space satellite or observational satellites, because you don't have to worry about it orbiting. You don't have to worry about really the sun overly so much. You have a lot more freedom in terms of what you can observe and when. Like, for example, the Earth sometimes is kind of in the way during certain times. So Euclid is out there with the JWST. Euclid's mission is to survey the entire sky, I believe it's the entire sky, over the span of its lifespan. And honestly, I am, as much as I'm touting it, I am fuzzy on the observational strategy of it. But what I do know, and what I'm most excited about, is that one of its primary missions is to use this data to figure out whether or not to characterize dark energy and dark matter. The way that it's going to do dark matter is it can see a lot of galaxies. It can see a lot of stars, when galaxies are most applicable in this case. It can see a lot of galaxies, and its instruments are fine enough that it can actually detect fairly small amounts of gravitational lensing. And so if you can figure out where the gravitational lensing is occurring and to what extent, you can then effectively map out where the mass is within the universe. And in those positions where there seems to be mass and no luminosity, then you can identify that as dark matter. Now, does it inform us as to what dark matter actually is? Is it, in fact, baryonic matter that is low in luminosity, or is it some kind of exotic particle such as a slow-moving neutrino? No, I don't believe it'll answer that question, but it'll better our understanding of how much dark matter there actually is, because right now it's somewhat of an indirect calculation, or somewhat of an indirect. We know you might hear that it's 24% of the known universe. That is not a direct measurement. It is very much inferred from other sources. And so Euclid will allow us a more direct measurement of just how much dark energy there actually is. Yeah, sorry. I should say this, the CWST, the Clyde Weld Space Telescope, it would be a better namesake, in my opinion. I appreciate James Webb, very much appreciate James Webb's contributions to science and aeronautics, but there are problems with him. So Clive, I think you are a far better representative of the Space Telescope. So yes, CWST. And so it will be able to do that with fairly high precision. And so we can map out dark matter that has direct implications to the current model of the universe, which CWJST has been showing kind of sucks, at least in the early universe, where the CWST has been making observations which are not what was expected using the cold dark matter model, which, as any good scientist would, if it doesn't match, then it's either going to have to be rejected whole cloth, or it's going to need to be seriously modified. And so that is essentially where we're at. And again, Euclid, I think, is going to help us do that. It's going to provide even more direct observations such that those models have better boundary conditions from which to work with. And then with dark energy, what it can do is that it will have unprecedented ability to determine the distances of things through Cepheid. What is it? Shoot, why am I thinking? It will use the Doppler. It will use the Hubble law. It will measure both, because it has both a photometer, or a camera, and a spectrograph. It can take visible observations of a galaxy, or infrared observations of a galaxy, such that will determine its that can be used to determine its distance, and the spectrograph can be used to determine its velocity. Bing, bang, boom. You can calculate what the Hubble law is at various epochs. At some point, I will put together a video where I talk about the dark energy model, and I will probably collab with Clive to do so that I don't say anything dumb. But again, Euclid will be able to do this with precision that is unprecedented from the ground, and it's not something that JWST or CWJST is going to be concentrating on, as far as I'm aware. So Euclid has the power. I have the power. Euclid has the power to really throw a wrench into the idea of dark energy and dark matter, or at least our understandings of them, or it can very well support these concepts in a more direct observational way. I think that ultimately, definitely in the terms of cosmology, Euclid is going to be the foundation of observational cosmology for the next decade. more so than CWST. And again, it is not getting the press that it should in the US. I don't know if the ESA's marketing division is doing its job, but like I said, it's not. I don't see a lot of news on Euclid. I see a lot of news on CWST, but not a lot on Euclid, and I hope to be able to change that. Let's see. This week's crisis in cosmology is the giant arc. I am not aware of that right now. I will look into that later on. Has the possibility of black holes been eliminated for dark matter? As far as I know, no, it has not been eliminated. But from my understanding, the observation is telling us that it's not likely. Again, I defer to Clive. He might be able to tell me whether or not that is now factually correct or wrong. But from my understanding, black holes still rely on baryonic matter to have existed. And right now, our understanding is that there simply is not enough baryonic matter created in the universe to actually account for the amount of black holes needed to explain dark matter. So, all right, I think that is where I'm going to leave off. Okay. So, thank you all for watching. Thank you, future people, for watching this on Memorex. And just to kind of recap what the stream was about, I talked about a paper dealing with the seeing too far problem. And in the beginning, I announced a few things. First of all was that I am now monetized to a certain extent. I can now get super chats, all that kind of good stuff. I made the caveat, and I have channel memberships. I will be working on that later today after I have worked on, primary job stuff. And just to be upfront, any monies that are coming my way, monies through Patreon or PayPal, will go to the observatory. Monies that come through YouTube itself, they go to me, because as I've said before, I very much would like a second income stream, and so I'm going to make a go of it and try to do it this way. So just again, to be upfront and honest, where your money is, your hard-earned money is going. Patreon, PayPal, think of the P's. The P's are going to go to the observatory, and YouTube is going to go to moi. And then lastly, I want to, again, preface this with whether or not I have the energy to do it, whether or not my mental health is up to the task. On Sunday, I am having an ambitious project in that I hope to have 3 streams. One early morning, at least for folks on the East, one in the late morning for folks on the East Coast, early morning for Pacific Coast, where I talk to Dr. Tapioca Weasel, who happens to be the grandson of Van de Graaff, that machine that sparks, that makes all the sparky stuff, makes your hair stand on end. His grandson is now a postdoc in physics, recently minted PhD. I hope to have him on Coffee and Science, where I basically interview him about how his academic journey, what he does for a living, and just, if you like Star Wars or Star Trek better. Fred, Clive, I'll get to that comment in a second. The next stream, or the next one that I'm hoping to be able to put together, that is tentative. I've reached out to Dr. Tapioca Weasel. He hasn't gotten back to me yet, but hopefully he will sometime later today. And then the second one that I'm hoping, and I will be more proactive as to try to wrangle the academic cats, is I want to put together, as I've said before, a forum on my channel of academics, scientists, active scientists who work in a variety of different fields, and can talk about how the scientific method, as was discussed in, high school or, yeah, yeah, I don't high school. I'm just gonna fuck it. High school science, and every introductory to science class that I had at university, how that how that framework of the scientific method is actually used in each of the um, various fields of study, because it is different. How a physicist, say, how a solid state physicist does their work is or is significantly different from how I do my work, or at least that's my understanding. So I personally know physicists. I know I know my brother is a geologist. Um, I can science that. Worked on is in computers, but I know that he also worked with rocketry, so I'm fairly certain he has something to say. I don't know a chemist. So if any of you know a chemist who would want to chat with me on this, please hit me up and send me their information. I would love to have a chemist on here. I would accept a biology. Sorry, science rivalry is picking up their heads. Nobody likes biologists. It's a science. Kidding. Any of you know a biologist who would want to come on, that would be excellent. Actually, that would be fantastic now that I really think about it, because biologists can talk, is going to be somewhat informed on the concept of evolution. And a biologist can make the argument of how evolutionary science conforms to scientific method. And of course, I'm sure we're going to relate all this back to why certain forms of science skepticism do not actually conform to the scientific method. So I'm hoping to be able to do that on Sunday as well. But the thing that I'm prioritizing actually is I will have a stream of indeterminate length where I celebrate the support that I have been given throughout this YouTube journey. Like I said, I have finally been monetized. Thank you, Judy, again for the super chat. She is my first super chat, and I think she had told me that she wanted to be. But where was I going with this? So yeah, it's going to be, I hit 500 a while ago. I've now got the viewing hours to actually be monetized, and I'd like to celebrate that. One of the things that I don't do enough in my life is self-celebrate. Which would be better for my mental health, to actually tell myself, hey, you have accomplished things. So I'm going to, again, predicated on my energy levels, I'm going to have a stream where I do that. The only thing I have planned for that is that it's going to be an open stream where people can come in and out and just chat about whatever they want to chat about. So I'll look forward to that. All right. So I saw dearth in here, and I'm like, huh, what's going on? Professor Dirt, mostly non-physical things that need a container. Yes, dearth I am not going to invite to my forum on the scientific method. Maybe, no, not really. I was going to say I could have some other stream where I bring flat earthers in and have them express what the scientific method is. But no, I really don't think I want to do that. I don't think it would be very productive. A 24-hour 500 sub stream. Oddly, or I have considered doing a uber long stream, in the sense that I have considered doing at least a 12-hour stream, continuous stream. I'm not going to convince. I am not going to commit to that. But if this particular stream turns into a 12-hour stream, then it could happen. I do not teach on Mondays. Today is MLK Day, so it's a holiday anyway, but my teaching schedule is jam-packed in the middle. I teach on Tuesdays, Wednesdays, and Thursdays. My Mondays and Fridays are effectively completely open. So a 12-hour stream is in fact doable within my schedule. But this chair is probably not comfortable enough for that. So maybe actually I could swap this for that at some point and do that. So that would be dangerous, because you all would get an insight to me over 12 hours. And I would expect at some point I would get very, very loopy and very, very weird. So who knows? All right. Anyway, thank you, all of you. I still haven't fixed the outro, but thank you to my patrons, Norman Dixon, Judy Bassett, and Dora Nakum, for contributing to my Patreon. I do have videos that are exclusive to patrons, and I will continue to put videos out there that are exclusive to patrons, particularly in terms of what their contributions have been allowing us to do. So, for example, this coming Thursday, we will be taking the planetarium out to a local, I believe, social center. I think it's going to be middle school center, middle school children. So I think around, I don't know, 8 to 12, somewhere in there. We're going to take planetarium out. We're going to show them a good time. And I will do like kind of an inside view, video where I just kind of highlight what's going on without showing the little ones' faces on the internet. So I'm doing that. And yeah, so this has been Professor Parks, PhD. As always, if you like astronomy content on mental health or science skepticism, please like, share, and subscribe, and click that bell for notifications, because I do not post regularly. With that being said, I wish you all a good rest of your day, whatever time it is you happen to be, and peace out and clear skies.